Today we're going to be starting the last section of chapter 4, so this is section 4.8, and this is the applications of the trig function. So again, kind of going back to SOHCAHTOA and solving word problems. So in our first example, the directions are going to say solve the right triangle if A is 34.5 degrees, B is 10.5, and C is 90 degrees. So in general, capital letters mean it's a degree, lowercase letter mean it is a side. So based on this information, we're going to draw our picture. So here's my right triangle. This is angle C. We'll put angle A down here in the corner. And that means this is angle B, and your side measurement is always across from the angle. So if angle B is in the top, that means the side is at the bottom. So this would be little c, and this would be little a. And when the triangle says solve the right triangle, or the directions say solve the right triangle, that means I want to know everything that is missing about the triangle. So we are missing angle B, we are missing side A, and we are missing side C. So easiest thing to calculate is angle B. So we know that there's 180 degrees in a triangle, so we're going to figure that out first. So we can say angle B plus 90 degrees plus 34.5 equals 180. There we go. So when I add this up and subtract from 180, I get that angle B is equal to 55.5 degrees. So I found one measurement already. And again, we're going back to SOHCAHTOA. So if I labeled this 34.5 my theta, that would be opposite, this would be hypotenuse, and this would be adjacent. So you can do any trig function. The only one you can't start with is sine, because I don't have opposite or hypotenuse. So you need to pick a trig function where you have at least one piece of information. So I'm going to go with tangent to start. So tangent of 34.5 will equal my A, which is the opposite side, over 10.5. And to solve for this, to get A by itself, I would times both sides by 10.5. So I'm going to times this side by 10.5. So what we would be typing in our calculator is that A is 10.5 times tangent of 34.5. And when I do that calculation in my calculator, we get 7.2. And now we need to do our next calculation, and that's to find the third side. So we could use cosine. It doesn't mean you couldn't use sine now. You can now use sine. You have the opposite side. I'm just going to use cosine. So cosine of 34.5 equals adjacent over hypotenuse. So over side C. So I have to times both sides by C, and then I would divide both sides by cosine of 34.5. So to find my C, I'm essentially going to be typing 10.5 divided by cosine of 34.5 in the calculator. We get 12.7. So now we have successfully solved everything that's missing about the triangle. So again, it's a lot of just SOHCAHTOA. So next example is going to be an application, again, a word problem. So if you need to, pause this screen so you can copy the entire problem down. So it says from a point on level ground 125 feet from the base of a tower, the angle of elevation is 57.2 degrees. Find the approximate height of the tower to the nearest foot. So we're going to be drawing a triangle, and because we're dealing with a base, we have a 90-degree angle. So from the point on the ground, 125 feet from the base of a tower. So here's my 125 feet. Angle of elevation is always the angle going up. So this angle right here is 57.2 degrees. And they want to know the height of the tower. So I'm looking for this piece right here. So based on this information given, we're dealing with tangent. So we will set it up. So it's tangent of 57.2. Oops. So 57.2 equals opposite over adjacent. To clear the fraction, I would multiply both sides by 125. So the way we would type it in our calculator is 125 times tangent of 57.2. And when we type that in, the answer that we get for x would be 193.9. Since the directions say round to nearest foot, we would say 194 feet for our final answer. Okay. All right, so we're gonna do one more application problem. The next one's a little bit more involved, but nothing that you can't handle. So it says a kite at a height of 30 feet when 65 feet of string is out. If the string is in a straight line, find the angle that it makes with the ground, round to the nearest 10th degree. So let's draw a triangle again. So we're going to draw a triangle. And here's our right angle. That's not too good. Alright, so here's our right angle. A kite at a height of 30 feet. So this is our 30 feet. When 65 feet of string is out. So 65 feet would be our hypotenuse. So here would be your kite. And here would be the person standing at the ground holding the kite. And they want to know, find the angle that it makes with the ground. So I'm looking for this angle right here. So based on this information, I'm looking for the opposite and hypotenuse. So the trig function that we use is sine. So sine of theta equals 30 over 65. This is where we have to use the inverse of sine to determine the answer. So what we would type in our calculator is sine inverse of 30 divided by 65. And again, you need to make sure you're in degrees for this calculation. So we get 27.4. It says round to the nearest degree, so 27 degrees would be our degree that it makes with the ground. So I lied when I said this was the last one. There actually is one more after this. Again, feel free to pause this video if you need to copy all of this down. What's important is the picture. When you go to have a test, you're going to have to be able to read the problem and create the picture yourself. So it says you are taking your first hot air balloon ride. Your friend is standing on level ground, 100 feet away from the point of launch, making a video of the terrified look on your rapidly ascending face. How rapidly? At one instant, the angle of elevation from the video camera to your face is 31.7 degrees. 1 minute later, the angle of elevation is 76.2 degrees. How far did you travel to the nearest tenth of a foot during that minute? So this picture, it's going to be involved. So here's going to be our hot air balloon. And here's the person standing at the ground. So remember, they're 100 feet away from the point of launch. So they're standing right here. It's a 90-degree angle. And the first time they look up, that little degree right there is 31.7. So let me make this font a little smaller. So 31.7 is this angle here. And then they want to know the distance, the height that you're at, that first initial height. Then they look at your height again a second time, but now your total angle is 76.2 degrees. So now you would be at this height of y. And if they want to know how far you've traveled in that minute, they want to know just this piece. So we're going to have to find those two opposite sides, and then we're going to actually end up having to subtract those two sides once we do that calculation. So make sure you have the picture drawn. I'm going to flip to the next page so that I can actually do the calculation. So I'm going to be dealing with this little triangle first. So I'm going to draw that on the next page. So this little triangle, again, is 100, and the angle is 31.7. So to find this piece, I would use tangent. So I'm going to be doing tangent of 31.7 degrees equals x over 100. To solve for x, I would multiply both sides by 100. So it's going to cancel. And when I type this in, 100 times tangent of 31.7, I get 67.8, so we'll round that to be 68 feet. Okay, so that's that little piece. On the next page, we're going to do the other calculation. So again, this is 100 feet. This is now 76.2 degrees. And I know about there is 68. But I need to find this whole piece of y. So I'm going to do tangent of 76.2 equals y over 100. And again, I'm going to multiply both sides by 100 to clear my fraction. So when I do this in the calculator, the answer that I get for y is 407 feet. But that has not answered the question to the problem. So 407 feet, again, is the total height. So 407 feet is this total height. And I know from here to here is 68 feet. But the real question of the problem was asking how far they traveled in that 1 minute time. So they wanted to know this piece here. So to figure out the final answer to the actual problem, I subtract the two. So 407 minus the 68. So in that 1 minute that they were looking, you've traveled a total of 339 feet. And that's the answer to the problem. So now I'm really am done for the day, and that is our last problem.